Have you ever wondered if there is an up or down direction in space? It's an intriguing question, isn't it? Here on Earth, we're accustomed to a world defined by directions. North, south, east, west, up, down. These terms are second nature to us. But have you ever stopped to consider why that is? Well, it's largely because of gravity. Gravity pulls us towards the Earth, giving us a sense of down, while the sky above us represents up. But space, my friends, is a whole different ballgame. In space, there is no up or down. The concept of direction as we know it becomes irrelevant. This is because gravity behaves differently in space than it does on Earth. And it's worth noting that our understanding of direction is largely based on our human perspective, a perspective that might not apply universally. Now let's dive deeper and see what happens when we leave the Earth's surface. Imagine yourself in space, floating freely among the stars. Now try to point upwards. Tough, isn't it? That's because the concept of up and down as we know it on Earth simply doesn't apply out there. You see, here on our home planet, gravity gives us a sense of direction. It pulls us down towards the Earth's core, and everything not nailed down with us. That's why we have an up and a down. But in space, far from any significant gravitational pull, that sense of direction evaporates. Instead, in the cosmic expanse, direction becomes a personal matter. It's all about where you are and how you're oriented. If you're floating headfirst towards a star, then that star is up for you. If you flip around, it becomes down. So in the vast expanse of space, up and down are merely a matter of perspective. But why does this happen? Let's examine the physics behind it. On Earth, we perceive direction due to gravity. When we talk about up or down, we're essentially referring to away from or towards the Earth's gravitational pull. Now let's take this concept and bring it to space. In the vastness of the cosmos, gravity is not exclusive to one single planet, but is exerted by every celestial body around, pulling and pushing in every direction. Now, enter inertia, the force that keeps an object in motion or at rest until another force acts upon it. When we're in space, far from any significant gravitational pull, inertia takes over. An astronaut floating in space continues to float until another force, say a push from a fellow astronaut, changes his course. There's no up or down because there's no singular force dictating direction. Every direction becomes relative to the observer's position and motion. In the end, it all comes down to the laws of physics. So, what have we learned today about direction in space? We've journeyed from our earthbound perspective, where up and down are as simple as the sky above and the ground below, into the vast expanses of the cosmos where these concepts take on a whole new meaning. In space, the traditional concept of up and down we know so well simply doesn't apply. You see, these directions are based on the pull of gravity, which in the infinite stretch of the universe varies and even disappears. This absence of a universal up or down can be a mind-boggling concept to grasp, but remember, it's all about perspective. We've also delved into the physics that governs these phenomena, exploring the role of gravity and how it shapes our understanding of direction. So, next time you find yourself pondering the mysteries of the universe or simply gazing up at the night sky, remember, in space, direction is all about perspective.